Hello and welcome to the Tapp feed calculations video here. What we're going to do is teach you how to do Tapp feed calculations. This one's going to be English. I will also do a small one on metric since they're a little bit different but not a whole lot. The process is basically the same. I've got a little quiz set up over here for you to look at. We're only going to do like 3 or 4 of them. It's not going to take very long. You do need a basic little calculator. I got it up here so you can see it. I still highly recommend a TI-85. Okay, so the things that you're going to come up with here. Now this is just the feed, and the feed is going to be expressed in inches per minute. That's why I said we're not going to do the metric one at this time. We'll do it later. So the two things you need to know, or the variables, are of course the tap size. Now we'll talk a little bit about tap designation, because right here's a standard tap designation. I can actually, this would be a more realistic. Oh, I cannot copy that. I am sorry. I can highlight it, but I can't edit it. Anyway, this is a pretty realistic tap designation. This is a half 13 tap. So the major diameter, that means if you were to take a mic over the outside of the bolt, it would be close to a ½ inch, plus or minus a couple thousandths. The pitch, that's the number of threads per inch in this case, because that's the way English is, number of threads per inch, is 13. So let's do that again. Once again, the ½ inch is the major diameter of the threads. Represents, if you macked over top of the bolt, it'd be about 500 thousandths or a ½ inch. And the 13 is the pitch, and that is the number of threads per inch. Now that's how it's expressed in English. In metric, they just give you the pitch expressed as a decimal, which is a lot easier, because what we've got to do is, the first thing we're going to do is we're going to convert this 13 right here, okay? We're going to convert that to a decimal. And then we're going to multiply that times our RPM. Now, I'm not going to do an RPM, tap RPM video, because it's pretty simple. The basic rule of thumb is, let's say you had a ½ inch drill, calculate up your RPM for that based on your cutting speed and everything, divide that by 3, and that's about how fast we run taps. Now that rule is a rule of thumb. It's not set in stone. You may have to find out if you have more difficult tap materials. You may have to go a slower RPM. With aluminum, you can certainly get by with a whole lot quicker RPM, things like that. So just understand that's just a rule of thumb for RPMs, 1/3 the normal. All right, so let's just do this one real quick here. So we're going to run it at 350 RPM. And we have 13 threads per inch. So the first thing you do is come over to your handy danny calculator, and we're going to 1 divided by 13 equals, well, let's try that again. Why isn't that working? Thumbs lock is on. There, I did not have it. 1 divided by 13 equals, boy, I would start over, but I'm not going to. I'll clear this there. 1 divided by 13. I can do this. Okay, so that's 76 thousandths and 9/10. What that means is, if I put a nut on this particular a bolt, a half 13 bolt, that nut would move 76 thousandths and 9/10 every time it completed one complete revolution. Every time it went around one time, it would move 76 thousandths and 9/10, practically 77 thousandths. And that's the pitch expressed as a decimal. So all you have to do is you take whatever the pitch is, here's the pitch, and you divide 1 by it, okay, and that will tell you the pitch expressed as a decimal. So that's how many thousandths per revolution this tap has to move, okay. Every time it goes around once, it needs to go down that far. Tap feeds need to be synchronized with the RPMs, or you will snap the tap. I'm going to say that again. Tap feeds need to be synchronized with the RPM, or you will snap the tap. So what we're going to do is, we know that most feeds are expressed in inches per minute on CNC mills, at least when we're in the English mode. So what we're going to do is, we're just going to take this number here, which is the pitch expressed as a decimal, and we're going to multiply it times the RPM, times 350, and you end up with what looks like a pretty ridiculously high feed. Well, remember this: every time that tap goes around once, it needs to move 76 thousandths. So if I'm going 350, that's not pretty unusual. Now, you do not want to round this at all. Do not round this. Now, I'm going to never put this whole number in there. You'll probably get an error. But two places should get you fine. Remember, most modern CNC machines have what we call rigid tapping cycles, which means they're more synchronized and things like that. You don't have to use floating tapping heads and stuff like that. That's old stuff. If you're using that, that's usually because you don't have a rigid tapping cycle. Uh, so that right there is the feed in inches per minute, 26.9. We go over here, 26.9. Very good. So let's go up to the next one. We'll clear this out. And the next situation here is we've got a quarter 20. Notice the major diameter really doesn't play in this at all. It's just the pitch and the RPM. The pitch, number of threads per inch, and your calculated RPM. So I'm going to do it the same way I did it before. So I'm going to go 1 divided by 20. Let's just click up here. 1 divided by 20, okay, equals 50 thousandths. Multiply that times 400 equals 20. So we're going to run 20 inches per minute. So right there it is, 20 inches per minute. Okay. Now, remember this, when you're programming this, you definitely need to put a decimal point in there. So don't forget your decimal point. Let's do this. Don't, clear it. All right, don't forget to put that in there. That will not work. If you don't put that decimal point in your program, you are going to come up with a broken tap. You will. You're just going to trust me on that. You will. Let's look at our next one. This will be our final example here. I got a 5/16 18, so I'm going to go click over here now that we know what's going on. 1 divided by 18 equals that. Again, that's the pitch expressed as a decimal. That's how far a nut would move in one complete revolution on this bolt, and that is how far the tap needs to be moved into the work in one complete revolution. So again, you don't want to round that any, 55 thousandths is what I'm going to go to on this one. I really am. So all we have to do is take that number times our calculated RPM, which I give it to you here is 275. So times 275, look at that. There we go, 15.277. Now remember, don't round anything but your final answer ever, and keep it at two places. Some people might even tell you to do it to three. All right, it probably wouldn't hurt. And if you do it in metric, you're getting a little anal, but in English, it probably wouldn't hurt. I'm going to round it to two places, so I'm just 15.27 ought to be fine. All right. So I look over here, and in this case, I don't have 15.27. I'm going, oh no, so I have to do that one all over again. So let's say 1 divided by 18 there equals 55 thousandths times our RPM, which was 275. We get 15 point. So in this particular case, it's none of the responses provided. All right. So to recap real quick here, all you're going to do is we're going to take the pitch. Okay. Then we're going to express it as a decimal, which means in English we have to do this. Okay. So 1 divided by 13 equals that. That's the pitch expressed as a decimal. That tap has to travel 76 thousandths and 9 tenths every time it goes around at least once. Then, to convert it to inches per minute, we multiply it times the RPM, which in this case is 350. And there we get 29.92, and we pick 20.92 inches per minute. All right. So that is pretty much all it is. But remember this, you do have to make sure that that feed is synchronized with your RPM. All right, very important. So that's how you do it. Later on, I'll make another little quiz for metric ones here and put it up there too, so you can look at it. All right. So it didn't take very long. Probably one of the shortest videos I've put up there. Have a good day, and I'll see you.